And here's example number 6. We have an object hanging from a string inside an elevator which is accelerating upward at 2 meters per second square. Question is, what is the tension in the string? And the easy way to look at it is, okay, let's see what all the forces are acting on this. We have, of course, the weight, which is mg, pulling down. And the tension in the string, as we mentioned before, is always going to be equal to mg plus or minus ma. Again, this component is simply the weight of the object, so the tension required in the string is equal to the weight of the object plus or minus the force required to accelerate it. And if the acceleration is upward, we use plus ma. When the acceleration is downward, we use minus ma. So in this case, it would seem to make sense to say that the tension in the string is going to be equal to the weight of the object plus the force required to accelerate it upwards against gravity. Plug in the numbers. We have 5 kilograms times 9.8 meters per second squared plus 5 kilograms times 2 meters per second squared. So that would be 49 newtons plus 10 newtons. So this is the weight of the object, and this is the force required to accelerate a 5 kilogram object at 2 meters per second squared for a total force required, or a total tension, of 59 newtons. Another way to look at it is to say, well, let me draw a free body diagram right here, like so. Let's put it over here. So here we have the tension and the mass of the object. So there's the mass, and we want to see what all the forces are acting on that. Well, for one, we have the weight pulling down, so this would be mg, and then we have the tension pulling upward. Now, since the object is moving or accelerating upward at 2 meters per second squared, we can use Newton's second law that says F is equal to ma. And so the force here required would be the tension minus the mg is going to equal the mass times acceleration. And then, of course, if we solve this for tension, we get tension is equal to mg, it becomes plus when we cross the equal sign, plus ma, which of course gives us the exact same equation that we had over there, but simply using the free body diagram method to do so. So here you can see how we can easily find the tension in a string for an object either being accelerated upward or being accelerated downward.